So how to build a server. I hope I have shared this with you. So here we have taken some port. So this port is something which is exclusive, right? So we'll be using the same port in order to connect to the client. Now let us try to create a client now. So I have created a new Eclipse instance here, or new workspace as such, right? Where I'm gonna create the client. Let me create a new client. Let me just say new other Java project. Sorry. So here let us create a class. It is called as client here, right? So basically here what we are going to do here is, again, let me write a main method here first. Now if you guys remember this, we had two things, a socket and a server socket. Server socket is something which is used to make your server up and make it run, right? And for communications and everything we have to go through the socket, right? So here in our server we created a server socket, right? Which after creating server socket, what we are doing is we are trying to accept sockets, right? We are trying to accept sockets and says whoever connect to this server and port, right? So they can actually get back with their sockets here, right? And we can actually accept the data being sent from the client, right? Now let's move ahead and write a client program here. So try catch here. Okay, so if there is an error, let us print that error here. So it's very important to handle your exception handling, because it is a network, right? We never know when the network breaks. As I'm writing something which is in my local, right? I'm making both my PC server and client, so there is no issues at all. Even if there is no network, right, it will be, communication will be done, because it will search for, if it is not able to search over the network, it will search in some hub where the IP is registered. In local, wherever you, in whatever point you want to search, the local host will be exposed, right? So that's why we won't be getting an error. But yes, over the network you may have to handle the issue. So now here we'll start again with socket. The first what we have to do is, so as we are writing a socket programming, right? So we have to connect this socket first to the server. Now how can we connect this? In this way, let us say it is skt is equal to new socket. Now you can see there are so many options like of creating your socket, right? Let's go to this option where you have to mention host. If you remember, host is nothing but a host name. Host name will give you the name of your current PC, right? Or you can also give your IP, or you can also say, if you have mentioned any name for your local host, you can give that. So if you remember, we said local host is a term which you can use for the local PC, right? And port, this port you have to mention the port of server. Now here, if you can see, we have taken the server port as 8899, right? So we have to give the same port over here. We have to give the same port 8899. Now this is, so by creation of the socket, right, it will directly go and connect to the server which we have created. If anything goes wrong here, if you don't give the correct port, right, obviously the connection will not be made, right? So this is the direct way to create a connection to the server, right? Now anyways, we have just made a connection, we haven't sent anything. Once you send something, then obviously it will start reading up, right? Now in order to send again, we have to use, again we'll be using the same IO thing, data we have used there the data input. So here we'll be using something called data output stream, right? Because it's an outgoing thing which we have to make sure that. So let us say it's a DOS, data output stream is equal to new. Again you have to create a data output stream which needs an output stream, the declarative pattern. Here output stream is over the network, right? So we have to get the network stream here. So what is the class which is creating network here? The socket, which means you have to get the output stream from socket, which is we have a socket dot you can just say output stream. You can see here we have an output stream, right? So this will give you output stream, which is now you have a channel to write the data into stream, right? So that is what you have created. Now let's go and say you can actually directly hard code the data, which is output stream dot, right? Now if you remember, when we created our server, right, we said we are going to read in UTF form, right? Which means your client should be able to write it in UTF, which is I can say write UTF. We have something called write UTF, right? I can directly say hello world, which I am actually hard coding right here. So now if you don't want to hard code again, you can use scanner, right? Which is scan is equal to new scanner, right, or some input stream. So we'll give something called system dot in, right, scanner here, and then we'll try to accept something, scan dot next, you can say, and this next is giving us some data. So let me catch up here. String, let us say lstr data is equal to scan dot next, and let's convert this to string. Anyways, you can give a string, but let's convert it. Fine. So now we have used this. Now let's copy this data here. So on fly we want to give the data, whatever we enter, we want to send that to the server, right? So once this is done, now immediately you have to clear the stream, right? So how to clear the stream in IO? We have to use something called flush. As we are doing the writing operation, right, we have to make sure the data whatever we are sending is being cleared once the complete packet is sent, right? So now your data has been sent here, now which means now we can close the stream here. Now how to close the stream? Always never close it inside try, just try to do that in a generalized manner. Make it here, remove this up, and write finally, right? And now clear your, you can just close. So before closing, just check if DOS is not equal to null, right? Now obviously you have to handle this IO exception, just say throws IO exception. Now here is what we have done. We have prepared a simple socket, right, with localhost and the port, which means this socket will be actually tied up with or gets the connection with the server, right? And then we have created output stream, because we have to create a channel using this socket where we can actually place some data. For placing some data, we are getting the data on fly with the user, and whatever data he is providing, we are just writing into the stream, which means whenever we are writing into stream, which means we are writing into socket. Whenever we are writing into socket, which means we are actually sending the data to the server. That is what we have done, right? And once everything is done, we have just closed the stream, and if you want, you can also close the socket. We have something called close, right? So what you can do, you can create the socket on as a global to this method. So once this is done, just say if socket not equal to null, right? So this check is very important because we never know where exactly it goes. If the connection is not made, which means there is null, right? So that is how you have to check everything as a null. Now your client program is ready. Now there is your client program where, so this client is listening to the local host and the port of the server, right? Now first what we have to do is we have to run the server first. So this is my server, right? Let me run the server first. Now when I run the server, you can see server has started and waiting for client, right? Until unless it gets connected to something, right, this program will be running continuously, right? Now let's go back here to this client part, right? And now let me run this. So let's see how it goes. Let me run this client. Now can you see this? It immediately, accepted the data, right? Received client request, client port is this, client IP, client data size, right? But we have to send the data, okay. So let us do that. Right? So it has to wait at this place. So it is not waiting. Show view of console. Right? You can see here now, right? I typed in something, right? It says whenever we actually create a socket, right? So it immediately connected to the server. The socket is nothing but this. Now you can see it created a separate port 4746 for my client, right? Because as we said, there should be some IP and port to the server, which we have mentioned, and some IP and port to the client, right? So client port you don't have to worry about. So whatever you actually whatever there is a port feed, it will take, not to worry. But you can see here some port has taken and some IP. So this IP is nothing but your local host. Now just remember that you can give local host or 127.0.0.1. this is a universal standard again. I mean all the Windows machines will have this as a local host, right? If you don't remember your IP, just give this, which is 127.0. this is called as a local IP. This will automatically be mapped as a local IP, right? Or you can just give local host, which means you're actually giving a true IP. So what is true IP? So true IP is something which you can see it in which your machine is being configured, right? Which is this, which is IPv4, right? If you can see this is a true IP, right? But yes, we have some nomenclatures. Either you can use localhost or you can go for this 127.0.0.1, which is called as a local IP. Now that is how you have got this client, right? If you can see here, right, that is how you have got the socket localhost, right? I can also give 127.0.0.1 because even this is running in a localhost, right? Let me run this again. Waiting for client, and let's go to the client part, right? When I run this, you can see, right? When I run this one, you can see I created a socket. When I create a socket, which means it will automatically comes to accept socket. It accepted socket. That's why it said received client, and client port is this, IP is this, and data size is. Now here you can see it is waiting. It is waiting in build UTF, right? Because as we haven't sent anything here, it is waiting here. So socket accepted until we send data, it won't move from this point, right? In the same way, if you are in client, until we write some data, right? Until we write some data, it is still running. Let's go back here and just say this is client 9 something, just enter it, right? Now you can see it has got some data. Anyways, so what we have done here is we have restricted our UTF. Maybe it is not get it should get the complete data, but it hasn't got, doesn't matter. It all depends on what data you are actually sending, right? Now let me run this again and send one more client here. Let me run this again and just say client data something, right? You can see this client here, right? That's how this works, right? This is how you actually design your server client program, right? Where you can see that we are completely working on the network using our IPs or local host, or you can give your physical IP too, right? It works in the same way. This is something which is called as a socket programming, and we call it as a connection oriented program. Why do we call connection oriented? Because you can see that in my socket of client, I'm actually connecting to the host here, right? If I'm connecting to the host, which means I'm physically asking that host to make a connection with this IP and the port of my client. So that is what we are doing. But this will not be the case with our with our datagram, where datagram is something which is completely connectionless, right? So there we don't will be dealing anything with IP. What happens is datagram will be just listening to the port, right? We'll be just listening to the port, whatever is there, right? On the port, whatever we receive, right, will be received from that, right? That is how it works. Now let's just see, let's quickly see the datagram program, how we can actually create a connectionless program, right? So as of now, whatever we have seen is a connection oriented one, right, which is connection oriented protocol. Let us see how we can actually create a datagram. So this is also called as you are actually making an communication streaming with UDP, right, which is nothing but a user datagram protocol, where for user datagram protocol there is no connection for this, right? But yes, how it works is it will just create a pool, throw the data, and whatever port is listening will get the data, right? Let's just quickly create that.
Srinath, Ujjwala here.
Yeah, Ujjwala.
Before that, I have one question.
Sure.
We get that client data size, right? What does it actually give us? Means whatever the data we are writing in the client.
Yeah. So
does it tell that one, or what is it? I am not understanding.
You mean this
client data size? Yeah.
Client data size. You mean this one? So this is there are two things actually, right? So buffer size is something I'm using something called received buffer size, right? Which means whatever data I am sending, we should get the size of that, right? Whatever client data we have sent, right? Sometimes what we get, the number of bytes of this will be getting, right? Sometimes what we'll get is whenever you make any connection with a socket, right? By default, there will be some message will be sent from server to or client to server by default. Right, or we basically call it as a socket heartbeat message, right? So it is a generic way of TCP IP that whenever you make a connection, right? Whenever you make a connection with whenever you make a connection from client to server, by default some messages will be automatically exchanged between client and server. That message is not something which actually you are sending. Whatever we have sent is our client data, right? But this is something where it has got internally transformed, exchanged with the client server, right? So that is what it is.
Okay. Right. And also when you gave some client like 2-3 words, why didn't it accept it?
See, the thing is like this. I am writing something which is UTF form, right? UTF form, right? So whatever you write, it didn't got here. It didn't got here. Maybe we are just writing into UTF. If you take the direct string, right? Maybe, right? If you take a direct byte array, right? You can also write something called byte array, right? Which is if I write some complete bytes, maybe I may receive the complete bytes here, and again you have to convert those bytes into your string. You can do that, I've just taken one
So if
form
we
of,
do that, we can give all the data.
yeah, you can give all data.
Okay.
There are so many things which you can read and write. Okay, you can see here. You can directly read. You can read bytes. You can read double. You can read float. Right? There are so many things actually. Right? I've just taken an example of UTF. Right? So that I just wanted to explain you UTF, which is Unicode Transfer Function. Okay. You can just try out with other things, right? If you don't get, you can just ask me. Right? Is that clear?
Yeah.
Okay.
Yeah.
Sure. Now let's create the datagram server now, right? Which is, let me take Java project again. Let us say datagram. So here there is nothing like server. Let us say sender, right? You can see in datagram there is one-way traffic, where you can actually server will be continuously sending the packets and the clients will be receiving, right? That's the only way how the datagram works. Now instead of calling it as a server, let me call it as a sender, right? And finish this up. Right? So here let me make it as, let me rename this rather, or how to name this, doesn't matter. You can create it with some with some name, so that you can, whenever I copy this code, you can just, let me call it as network datagram sender, right? So that you can just see both the things that I said, right? Now here let me create a sender now. Right? And finish. I can see we have created a simple sender. Now, so here the basic principle here, what we are going to do is, we are purely creating a datagram. So you don't have to worry about whether you want a socket or something. You just create a datagram, create a stream, put some data into that, and it should go. That is what we want to do here, right? So here, if you can see, for datagram we have two things which you have to keep it in mind, which is datagram socket, which is same as the socket which we used to use, but the difference is this is connection based, and this is something which don't need connection. It will just throw the data into pool. And for data transfer, we will be using datagram packet. Datagram packet is something which will actually read how much of what exactly the number of buffer size I am getting. So it will actually map the buffer size from start to the end of this, right? We'll see how it works. Now here first let's go and check out our datagram program. This is my client. Let's go to the server part. Yeah, so here, now first what you have to create is, now obviously before starting anything you have to create a socket. Fine, let us create datagram socket. You can see again the datagram socket is again a class in your java.net, right? Let us call it as LOBJ socket. Datagram socket is equal to new datagram socket. Now here so how we can use this datagram socket is, anyways we don't have to give IP and port to the client, but here whenever you are creating a datagram socket, right, obviously what you have to give, you have to mention something called on which server you want to start the port to actually throw out your messages, right? That is important. So let me just create a message here, which is string, let us say lstr data is equal to, let's say welcome something. I'm just giving some data here, right? And what we'll do now, yes, we have to use something called datagram packet. If you remember, datagram packet is something which we'll be using to make a communication. Now if you remember previously what we have used something called stream, right? Now where do we use stream? IO streams, where there is a physical connection between a file and a program, or over the network in between servers. Until then you won't be creating these things, right? Now here in datagram or in this UDP model, right, you won't be going to streams. You have a direct class which is datagram packet, because you just have to create a data and throw it into the pool of the port. That is what we have to do. For that we don't need stream, we will be using datagram packet. So let us say we have something called DP, datagram packet, is equal to, let us see what actually it needs. Let us take this one. So it is asking for, so how many bytes you are sending, how many bytes, let us say, or how much data you are sending. Let us say I can take some get bytes, okay, because I want to send it as a byte. You can see here, right, it should be byte array, which means I have to convert this into byte array. Okay, if you don't want to give directly, maybe I can just, for much better understanding, let me create a byte array. Let us say lbyt array data is equal to lstr data dot get bytes. So this get bytes will give you bytes of the string, and replace this with this. The first argument is that, right, and second argument is what is the size of data, right? So for that, what you can do, you can just say size is, just say length, right? This is the length of your data, or obviously you can directly say the length of this, right? And the next one is the network IP. I hope, right? These are the network IP. You have buffer and you have the length of that, and yes, it is either a socket address or you have to give INET address. Let us create an INET address here. INET address is nothing but I'm just creating instance of IP here. LOBJ IP is equal to new, I can say INET address. I have to get the IP of this INET address. I can just say something called get by name. Yeah, I can just say by main name will be actually, let me make it as 127.0.0.1 because this is my local IP. So I can use this INET address here, right, which is IP. And the third option was, it was buffer length address and port. Yeah, you have to make one port here. Let me make some port as 3 or maybe 7 3007 and close. Now your datagram packet is ready. Here you just created a datagram packet with your INET address with some IP, and your data is ready. Now you have to send this now, right, because your message is ready. You have to send this now. In order to send this, obviously you have to use a stream, which is a socket. Let us use socket dot, we have a direct method called send, right? Send a datagram packet. Okay. So send it, and once you send it, once this is done, what you have to do, you have to close this up. It's equal to null. Let me make it as null, and in here let us handle error. So if there is any error, we can just check it out. Get message. So here in finally, just go and say lobj socket dot close, right? So before this, just check out whether socket is not equal to null, right? Now this is how we create a socket datagram program, which is, we can say it's a sender. It is a sender, right? It basically sends the data, right? Now let us create the receiver now, because sender anyways, if it is sending continuously, it will be receiving it, right? Now let's go back and create a receiver, right? Because it should be exclusively, so when I run this, it should send and the receiver should accept, right? Let's go back to the next here. This is my sender. Let's go back here and just create one more project here. Just say network datagram, I would say receiver, right, and finish. Now here you have to create a source where it can receive the data. Now this is something which where you can just see how we are making a connectionless one, right? Now let me create main here. Now again here, if you want to receive some data over the network, again you have to create a socket. Socket is mandatory, but what type of socket you are creating is something which you have to decide, right? Now let us say we want to create datagram socket, right? Because we don't have a physical connection now. Let's say we have datagram socket, right? Let us say LOTJ datagram SKT is equal to new. Now here you can see something. If you want to actually listen to any port and INET address, you can do. Even if you are giving some port and INET address, right, which means it is not actually making an connection. What it does is it will just go to that IP, it will just wait at this port. Whatever data is coming, it will just read up. That is what it happens, right? Why? Because even if you give the port and address, we are not actually accepting any sockets here. We are not actually accepting anything, which means we are not actually, if you are not accepting any socket, which means you are not actually making any connection. That's a simple way, right? Over here, what we'll be doing, as we know that we don't have to give address, right? Why? Because we are working in a local host, so I can directly give my port. Now what is a port I've used here? I've used something 3007, so I just have to give that port 3007 so that this datagram socket will continuously read into that, right? So why I'm getting this, okay, I have to handle the try catch, or let us just take this try catch, so that, right, I'll be getting socket exception, right? So this exception, and let me also catch the exception also, so that
Srinath?
Yeah, Jami?
Yeah, instead of 3007, can we give any number? I mean, if we give the same number or two?
No, you can give any number, but the only thing is there is some set of things which you should not use, but yes, you can give any number. I'll give you the detail, I'll give you the set of ports which you can use, right? I'll give you what not to use and why we should not use. But yes, it is not only 3007. You can give anything. I just gave some random number, whatever I thought of. You can just give maybe 97. Doesn't matter, right? But only thing is you have to maintain whatever you are giving in a sender. You have to make sure you are giving the same thing in a port. That's it. Fine, Jami? Hello? Okay, so as I have mentioned 3007 in my sender, right? That's why I'm taking the same port here. Why? Because obviously a port is something from where we'll be reading the data, right? It should be same. If I give some other port here, which means there is no datagram sender itself over there, right? Obviously it is not true. But yes, you can take any of your port, but there is some restriction. We'll talk about that restriction tomorrow, right? I'll give you that. Fine. So here now what we have to do, we have to again create a data packet here. Datagram packet will dp is equal to now. So what we have to do here is we have to read here, right? Which is new. You say datagram packet. Now here you can take this one, which is the bytes here, byte buffer, and how much I want to read. Now let us say I have to create a byte array here. So in order to get the data, right? Byte array, let us say I'm making it as byte arr response method, right? Is equal to new byte array of, now the standard byte array size which we use per time is 1024, right? Now here let me make this and let me give the same data dot size maybe or length. You can change this size, guys. You can change this, doesn't matter. But only thing is till this size, because see, whatever data we are getting from datagram packet of sender, right? We don't know how much is the size, right? So what you have to do, you have to actually give the maximum size where you can read the whole packet. But basically in general, the packet in over the network will not go beyond this size, right? So here now what you have to do, you have to receive that. Now how can you receive? So we have created datagram to receive. Now obviously you have to receive using the socket. Now let me just go to the socket dot. Now, so initially we have seen send, right, where you can send. Now you have something called, yes, receive of your whatever data is being received will be mapped to datagram packet, and this datagram packet will map that message to your byte array. This is one, right? Now let us map this here to some string. Let us say lstr data is equal to, now what you have to do, you have to map your arrays into this. Now how can we do this? Let me just say new string so that you can create an object, right? New string of, I want to get data from this dp, lobjdp dot get bytes, get data maybe, yeah, get data, right, comma, and then you have to mention from which point you want to get. I want to get from 0th index to the complete data, which is data protocol, which is datagram dot, I have something called, yes, I have something called get length, right? Now this is how you do. I want to get a string from this, and this is something which is a format of string. You can see whenever you create a new string, you have so many things. If you remember, we created something, right, where we had so many things. Now here we'll be using this part, right, where you're actually reading a byte array, and either you can give offset or you can give this. So int offset is nothing but from which point you want to read. Offset is nothing but an index here, right, where I want to read from 0, and you can just say how much length. I said this. Now this should map your data, and now let us print this data. This is how, just say data received, maybe you can just say lstr data, right? Perfect. So now once your data is done, right, maybe what you can do, you can just close up your socket. Close up your socket and just finally, right, just save your socket. It's not a big name, right? So this is how it goes. Now here you don't have to worry about the packet class, because this packet class is completely tied up with sorry, completely useless until you actually use your socket to receive that packet, right? This is something which you are creating a object to read the stream or read the UDP data, right? But if you are actually closing this up, which means even this will be closed, right? Now you have created your client here. Now let me close this, right? Now we have created a client. Let me run this. So if there is no data, I don't know whether it will run. Let's just go back to the server. So this UDP is something where your server should be continuously running and your client should work. When I click on this, right, yeah, can you see this? Data received, right? We haven't made any of the connection, right? So when I click on this again, now again you can see my process is running, right? Until I get some data, it will be stopped here. So here I'll send it. It doesn't care. This sender will not care whether the data is being sent or not, right? Because this is UDP. Now let me close this program. Now let me clear this. Now let me run this. Now here you can see it is not in process. Why? It will just throw the data in this port and that's it. It won't even stop. It will just be throwing the data. That is what it does, right? And where it is actually throwing into the network. That is what actually we are receiving the same thing in here, right? That's how we actually do the connectionless program in a server and a SOC, right? So that is what is the data being sent and received to the different protocols over the network, which is TCP/IP and which is connection oriented protocol, and your DUDP protocol, which is connectionless, where you won't be making any physical connection, but yes, you will be sending data across the network, right? Now here there is one point which you have to remember. As of now, I've taken only I'm sorry, where is my client here? There is my client, right? Sorry, receiver. Now here you can see I've taken only port here, right? Now, but yes, this won't be the case. Sometimes you may have to go to the INET address also, right? because it's very important even to give the IP of the server where your UDP messages have been sent, right? So in that case, you can just go to the INET address, just give the address of that, which is like, you can give port 307 comma, you can just mention some INET address, which I can take it as new INET, or I can just say INET address dot get by name of some, which is maybe 127.0.0.1, right? This is how you can also give this data, right? Let me check whether this receives this data, right? So this was my receiver, and this is a sender, right? Let's go back and start my receiver here, and now this is my sender, right? So let me run this sender now. When I click on the sender, yeah, you can see the data received. But yes, you have to go for this IP, as I didn't give IP previously because it's my local IP, right? If I don't give any IP exclusively, which means it's a local IP, right? But here anyways it is working fine with us, right? You can give your local IP, or you can, so this is something which is your client server programs, guys, right? Which is connectionless and connection. Now basically always do remember, all your servers will be running in a separate thread, right? Separate thread, and all your receivers also will be running in a separate thread, because this is something which I have created for one request and one response, right? So your sender is sending request and your receiver is receiving request, that's it, and we're actually doing nothing, right? We can actually create a server continuously to get the data. We can do that, right? Which will continuously get the data and the process the data. You can also do that. Just you have to keep those things in an infinite loop by creating a new thread, right? You can just try out, but this is a way how you can actually create a network programs. Fine. So any doubts here? So over this datagram, I hope you understood the connection oriented and connectionless program, right? I just gave these two examples so that you can actually understand whenever we go to HTTP. Fine. Any doubts over here, guys? Sai, Jomi, Ujjwala, Prakriti. So I hope this is clear. You can just try out the same thing, right?
Srinath, Ujjwala here.
Yeah, Ujjwala.
Do you have any book or something like we can go through and read some concept, because these are all new concept for me, so it's not that easy to understand.
Yeah.
Just
actually,
if you have any notes or a website, that we can go through.
There are so many. I always go through complete reference. Actually, you know the complete reference Java, right?
Yeah.
I mean McGraw-Hill's ones. So that's a best book.
Yeah, I have that one. Okay.
Yeah, the concepts. I mean, whatever.
What is that book, Srinath?
It's a complete
reference.
Java complete reference. The name of the book is Java complete reference. Okay. It's McGraw-Hill's ones. McGraw-Hill's ones. Right.
McGraw-Hill's, okay.
McGraw-Hill's, yeah. It's a McGraw-Hill's one, or you can also see Tata McGraw-Hill's one, because here or in India they are the suppliers, but I don't know about. I think you will be getting this Java complete reference is a universal one, yeah. Or
it's McGraw-Hill's.
Yeah, it's a McGraw-Hill's one, or you can go to Head First. Yeah. Head First Java.
So you have shared the Head First. So does it has all the concept?
Yeah, it should have all. It should have all the. But for core Java, I think this is Head First is best one. I won't say best, but basically, based on when we compare this with complete reference, right? I don't think this is for understanding complete Java. This is the best book. But yes, to start with basics, you can go through Head First. Yeah. Even your Head First will have the networking thing. I don't know whether this have got Java network thing. This will have the complete concept.
I think it has. Head First has networking socket and multi-thread.
Okay. Yeah, you can go through that. So whatever you have to understand. I've gone through. I've explained these things. But yes, you can go through this book. If you get anything, I can explain you on that. Right?
Yeah.
but yes, and it will be tough to actually initially go through this book. Which is like, let us say this is your web server where your website is there, and you want to show the data, market data, which is, let us say this is rediff.com, which shows a market. Let us say it's Rediff money site. Now before populating or before filling up the site, they'll be having separate server. Again, let us say this is a separate server which is directly connected to the stock market server, stock server. Now this server is actually throwing data into port, and this server, which is a Rediff server, again is reading the data, and all the data, whatever it is reading, is saving in its database, right? And this website, whenever you browse onto this site is actually looking up into data, and then it is showing to the client. So this is how it works. UDP is working in this way, because UDP works over the network. You need some network directly, right? Because in between your server and this site, right, you have something called internet hub. If you remember this, there is something called your internet hub, right? You can't take a chance reading data over the hub, right? That's how it goes. Is it clear, Jami?
Yeah.
Okay, fine then. So if everything is fine, you can just go through that. Let me just find out if there are any URLs which I can share, right? So we'll start with servlet from tomorrow. Fine. So that's all. So let's wind up the class here, and